Hey folks, welcome back to Waygate Technologies. Dan Groninger here, and I'd like to share with you today some exciting new features that have just come out with revision 1.5 of our USM100 instrument. We've added encoded and timed BSCAN and CSCAN to the instrument. It's very exciting. It's our first offering in a conventional flaw detector to include those capabilities. So to start out, we're going to look at a couple of different applications, and we're going to take a quick look at an encoded hand scanning application. I have a KBA 560 probe here to which I've attached a small magnetic wheel encoder. So that'll allow us to track the movements of the probe on one axis. We'll go ahead and use the generic app that we distribute with every USM100. When you do update your instrument with the latest software, be sure to always grab the latest generic app to go with it as well. So there I launched the app. We're going to start from scratch. First thing we're going to do is set up our probe. We are dealing with a straight beam probe, so 5,900 meters per second is good for velocity. We're going to be working with a carbon steel step block. My probe is 5 meg. I'm going to put an initial probe delay of about 8 microseconds in. That's going to be in the ballpark for this KBA 560. And we will not worry about anything else on that panel just yet. I'll give the pulsar a little bit more voltage. Rep rate is okay. Square wave pulsar. 5 meg, full wave's okay, and it's a dual probe, so we want to be sure to turn dual mode on. If I put this on our 1-inch step of the block, see we have a little bit of an echo coming up here at 25 millimeters, more or less, so we're in the ballpark with probe delay and velocity. Do auto 80, get ourselves a nice echo, and now we can move on to doing our 2-point calibration. And we'll go to our cal menu. We're going to do a multi-step calibration. We're going to go with 12.7 millimeters, a 1/2-inch step, and a 1-inch step. Okay. So let's go to our 1/2-inch step. Peak up, hit calibrate. Go to our 1-inch step, peak up, hit calibrate. And we have 59.91 and 8.38. So there my gate is measuring 25.4. 3/4. And there's the 1/2-inch step at 12.7. Okay, so we've got a decent thickness calibration. Now we can, since we're doing straight beam inspection, we're going to skip our angle calibration and we'll skip our eval mode. We're not really all that interested in DAC or anything. This is a pretty straightforward application. So let's just take a look at encoder calibration. So again, I have a little magnetic wheel attached to the back of the probe holder. So let's swipe out our sidebar menu and take a look at a few things. We're going to do a quadrature encoder. This is only a 1-axis encoder. And when we get to our scanning tank, we will look at doing both the X and Y axis. We refer to the X axis in the Mentor instruments as the scan axis, and the y-axis is the index axis. Okay, so we're just going to calibrate the scan axis. We'll let the direction set as normal for now. We can ignore the y. The default ticks per millimeter is actually roughly correct for this encoder, so we can leave that alone. If we happen to know that our encoder is, say, 20 ticks per millimeter, we can set that here as a starting point. Next thing we're going to do is tell it how far we are going to move the encoder during calibration. So I'm going to bring out a ruler, and we're going to take a look here. I'm going to use 200 millimeters as an expected distance for my encoder calibration. So we'll set this to 200. I'll put the probe down on, and I'll set the bottom of the wheel right at 2 on my scale. Okay. And what I'm going to do, the encoder calibration happens in 2 steps. We set a starting point, hit calibrate, we move it the expected distance, and we'll move it 200 millimeters along the ruler, so from 2 to 22 centimeters on the ruler. Hit calibrate, and then it's going to want to check backlash, so we'll get back to our original position at 2 centimeters and hit calibrate one more time. So we'll do calibrate. We'll move our wheel to 220. Hit calibrate. Move it back to 20. And the encoder is now calibrated. Okay. So if we look, the ticks per millimeter are slightly different than they were before. It went from 1604 to 1658, but the encoder is now calibrated. Okay, at this point I can go to my scan panel, take my ruler out of the way, and I'm going to flip my block over so that I can do a smooth scan out along all the steps from one end to the other. All right. Now I need to set up my scan parameters. So I tap here on the CSCAN, on the overview CSCAN, and I am going to be doing a line scan. It's encoded. I'm going to do a scan size of, how long is my block here? My block is 275 millimeters long, so let's say we're going to do a scan size of 280. Okay. I'm going to use a scan resolution of 1 millimeter, so I'm going to take a reading every 1 millimeter along the length. If I wanted finer resolution, I could take that number down a little bit, but 1's a good place to start. The active scan size, we can make that 280 as well. So here on the display, I have 2 CSCAN windows. The left one is an overview CSCAN. It's going to show me everything that is part of my entire scan that I record. Then I can lay down cursors or draw a box on that screen, on that overview CSCAN with my finger. And whatever's inside that box is the data that will be displayed on what we call the active CSCAN here on the right and on the BSCAN at the top. So with that, I believe we are ready to go. Not much to the setup. I put some couplant on there, and I'm just going to run along. Okay, so first thing I need to do is widen my gate a little bit so that I can get a reading from anywhere along the block. And bump up our gain a little bit. Okay, we're going to hit clear, record. There we go. Stop. All right, and I had a little bit of trouble as I ran off the end of the part here with the scanner, but you can see I got a nice scan of the step block. So I've got color-coded gradations for thickness on both the overview and active CSCANs, and on the BSCAN up here I can see the individual steps. So let's see, we can select an area here, have a look at the active part of the CSCAN, and you'll notice what's highlighted by the box here is what is selected for width on the active CSCAN and on the BSCAN. Now on the BSCAN, I can draw a box. the crosshair will snap to the highest amplitude that's seen within the box, and we get some information. So I see that my min thickness is 25.4, my max thickness is 25.75. So that is looking at minor variations within the box of thickness. If I open any of these views, can be blown up to full screen by double tapping on them. Okay, there's the active CSCAN taken to full screen. Take the BSCAN to full screen. The BSCAN also has some very useful box tools. I can draw a highlight box around one of the steps. Again, I can see the thickness to that step. I can see the length of the box. There's amplitude information, all of that displayed. And again, the crosshair is going to go to the highest amplitude reading in a box. For any of these, if I grab just the crosshair and move that around, you can see the A scan is going to display whatever is underneath the crosshair. So again, if I select each of these steps, we can see how the time of flight of the A scan changes as I sweep across. So all sorts of intuitive tools for working with that scan. Now I can come down here and save the data. And let's give that a name that we choose. Let's call that long step block. All right. Now let's say we want to share that with someone, or we want to take it to our PC for further analysis. One of the easiest ways to do that is to go to our file manager. There's the file that we just saved, and we're going to export that, and I'm going to send that to my InspectionWorks account. Okay, I've already got the instrument registered to the account, and we see that completed success, and there we're back to our scan. Let's move over to the PC for a moment, and we'll start by taking a look at my InspectionWorks account. I've already logged into my InspectionWorks account, and if I look in Insight, the top file in InspectionWorks Insight is the one that I just uploaded from my USM100 PC. So just to work in Insight here for a second, one of the first things I want to do is rename this to make it easier to find. By default, when we upload a file, when we upload an inspection from USM100 PC, it will be named with the name of the app that generated the data and dash, and then the serial number of the instrument. So I know that 0041 is my instrument. This is one that I just updated. So I'm going to come in here. I am going to rename this file, and I'll call it long step block. So I'm actually renaming the inspection in InspectionWorks. So now we see long step block. If I click on that and I look in here, I have one data file, and it's the one that I saved on the instrument. Now, if I want to look at that in USM100 PC, I just come here, click download, and we see that the file has downloaded. So now let's switch over to looking at our USM100 PC app that I have open. And the easiest way for me to view that data file is to go to Add App, Downloads. That's where Chrome put the file for me. And there is long step block. Okay. We're going to import that. So USM100 PC will install the app. It will launch the app. And now that we have our file loaded, let's look at some of the analysis features that we have available in USM100 PC. First of all, let's review. In the upper left corner is the A scan, upper right corner is the B scan, lower left is the overview C-scan, and lower right is the active C-scan. So if I put a measurement box down on the overview, that selects what appears in the active window and the BSCAN window. So the BSCAN and active window align vertically, and the BSCAN aligns with the ASCAN vertically. So wherever I place a measurement cursor on the CSCAN or the active BSCAN or over here on the overview, the point directly under that cursor is going to be what appears on the ASCAN. So these views all sync together. So if I stretch my measurement box out to include on the active to include the entire area that I scanned nicely, we get a good look at our block. Now, on the active CSCAN and BSCAN, I have measurement boxes that are available as well. So if I place, click and drag, and this would be the same thing as placing my finger on those on the instrument, I can touch and drag a measurement box. And by adjusting the edges of the measurement box, I get some interesting information in the little window that pops up. So the length is going to be the length along the scan axis. Width isn't as useful here because we only acquired one stripe of data. So our vertical distances aren't all that meaningful on this type of line scan, but the length of that box is a good indication of the actual distance along the scan axis. So my box, as I drew it there, is right about an inch, 24 millimeters and change. I can draw those same boxes on the BSCAN, getting to where the echo for that really begins to drop off, so sort of center of the transducer. So there's, again, showing about 25 millimeters of length. On the BSCAN, the cursor is going to snap to the highest amplitude anywhere in the box. So we get a good look at the ASCAN that goes with the highest amplitude that we saw along the length. And again, we get various pieces of amplitude information, time of flight, that sort of data in that box as well. If we want to make those boxes go away, that's on the display menu. Turn the stat box off, and we can hide those, but they will come back on when we draw a new box. All right, so that's some of the analysis features. One more thing I would call your attention to here. Let's take a look on the CSCAN. And we'll go to the display menu. We have a new feature also available in 1.5, and that is the thickness palette. So if you're doing corrosion thickness scanning, sometimes you have a procedure that says, all right, the nominal thickness of the part is, and we defined that earlier at 2 inches, 50 millimeters. Let's say that our minimum thickness is going to be 40 millimeters. So what that does is allows us to set some thresholds such that anything above our minimum thickness is going to show as green. And this only works for a time of flight or a thickness data view. But we've said our nominal thickness is 50 millimeters. The minimum thickness that we want to consider as good is 40 millimeters. And then we have several bands of increasingly bad below that. So we say at 80% of anything between 80% of 40 millimeters and 100 is going to be blue. Anything between 60 and 80 is orange or taupe color. Anything between 50 and 60 is yellow, caution. And below 50% of minimum thickness, we want to see red. All right, so this is a very useful feature if you're doing corrosion scanning. The step block is maybe not the most interesting piece of corrosion data, but this gives you the idea of how the new thickness palette is intended to work. So thickness palette's either on or off. Other than that, you have the standard amplitude and times of flight palettes to choose from. Okay. So those are some of the analysis features that are available on both on the instrument and in USM100 PC. So with that, we'll wrap up. Again, thank you for joining me. And if you have any questions, please feel free to reach out to remoteservice@bakerhughes.com, and we'll be happy to get those answered for you. Thanks a lot.